Similar to batteries, there are different ways to classify or categorize fuel cells, and one common classification is given here. Okay, the first column represents fuel cell type. The second column represents the ionic species that got transported through the electrolyte. And then the third column represents electrolyte material. The fourth column represents the anode material, active anode material. The fifth column represents the cathode material, not the cathode half cell reaction. And the last column represents the operation temperature and their applications. Okay, the first one people say would be direct methanol fuel cell. Direct methanol fuel cell, which means fuel here would be liquid methanol. Okay, CH4 the CH3OH. Okay, methanol fuel cell. And in short would be DMFC. The ion species that got transported through the electrolyte is proton, and the electrolyte material used is quite often a polymer electrolyte. It's an electrolyte material that is polymer, and quite often the material used is a brand by DuPont Nathan material, superionic conductor. And the anode for this type of fuel cell is quite often either platinum, pure platinum, or platinum ruthenium alloy. The cathode, where the oxygen molecule got reduced, is mostly platinum. And the operation temperature for DMFC would be 20 to 90 degrees C, and in principle they may find application as power source for portable applications, like single soldiers, camping, power source. A second category is called a proton exchange membrane fuel cell. Sometimes people also call a polymer electrolyte membrane fuel cell. Either case, proton exchange membrane or polymer electrolyte membrane fuel cell, PEM fuel cell. In this case, the ionic species that goes through the electrolyte is still proton. The electrolyte material used is mostly Nathan polymer electrolyte. Of course, there have been many other polymer electrolytes that have been studied, but the most common one is Nathan polymer electrolyte. The anode, where the hydrogen molecule got oxidized, is still platinum based, while the cathode, where oxygen molecule got reduced, is also platinum. These types of fuel cells operate at a slightly higher temperature from 60 to 90, close to 100 degrees C, and the people primarily target PEM fuel cell for automobile power source as a primary power source for an automobile, for a car, or even a truck. So these are the applications for PEM fuel cell. It has been semi-commercialized, which means not widely used, but you can see them in fuel cell vehicles such as Toyota Mirai or Hyundai Tucson. The third type of fuel cell is called alkaline fuel cell, or AFC. Alkaline, of course, the ionic species that got transported in this case would be hydroxy group OH minus, and the electrolyte quite often would be potassium hydroxide, of course dissolved in most cases water. The anode would be nickel metal, and the anode is in contact with hydrogen gas. The cathode can just be silver metal. The operation temperature is from 80 degrees C to 100 degrees C. Okay, and this one has the advantage that you can avoid the use of precious metals such as platinum, but on the other hand, because the electrolyte is potassium hydroxide, it is susceptible to poisoning or degradation by the carbon dioxide in the air. Okay, A fourth type of fuel cell is called phosphorus acid fuel cell, PAFC. P phosphorus, A for acid, PAFC. And in this case, the ionic conducting species is still proton, and the electrolyte quite often people use would be liquid phosphoric acid, saturated phosphoric acid. The anode and the cathode are quite often still platinum. The operation temperature is slightly higher than PEM fuel cell or direct methanol fuel cell or AFC, quite often around 200 degrees C. Can be a little bit lower, can be a little bit higher, depending on temperature and the gas atmosphere provided. The fifth type of fuel cell is called the molten carbonate fuel cell, MCMC. Molten carbonate fuel cell, FC for fuel cell. Okay, and in this case, the ion alkyne carrying species would be CO32 minus. Okay, CO32 minus. This ion and the electrolyte is quite often a liquid mixture between lithium carbonate and potassium carbonate. These two form eutectic and melt at relatively low temperature. The anode, you can use a relatively inexpensive metals such as nickel, while the cathode could be compounds between lithium oxide and titanium dioxide, or lithium oxide and nickel oxide. These are the cathodes that have been studied. It doesn't mean those are widely used, but they have been studied and seems to show some viability, some feasibility. It doesn't mean they are the perfect. And for MCFC, molten carbonate fuel cell, their operation temperature is quite often around 600 degrees C, and as a result, they can provide stationary power as well as waste heat for thermal exchange and better use of the energy from the system. And finally, we have solid oxide fuel cell, SOFC, solid oxide fuel cell, and the ionic species would be oxygen, more 2 minus. It's essentially the same as oxygen vacancy with 2 plus. And the electrolyte, if we are talking about the oxygen vacancy electrolyte, quite often is 8 molar yttrium doped or yttrium stabilized zirconium. Okay, and the anode in this case, still we can use relatively inexpensive metals such as nickel, while the cathode can be complex oxides such as what we show here, LiCF, lanthanum, strontium, cobalt, iron oxide. It's a structure similar or related to perovskite, AbO3, but it has different stoichiometry at the A side and at the B side. And typically, the solid oxide fuel cell operation temperature is above 600 degrees C, up to 1000, quite often around 750 to 1000 degrees C. And they find application as stationary power source. In fact, it is not very suitable for portable power or automobile because this high temperature needs long time, several hours to heat up, but you don't want to be stuck in an empty automobile for several hours in order for it to move. Okay, so here we presented one type of fuel cell classification. Of course, there are more, and don't forget that when you come across them, each of them have its own advantage and disadvantage. Okay, and nowadays most of the current research have been focusing on either PEM fuel cell, this one, for automobile application, or solid oxide fuel cell for stationary distributed power generation. Okay.